So today we're going to look at rational equations and we're going to try and solve them. So let's see what we have. So we're asked to solve the following rational equations. All right, so the first one is, well, I guess first thing is, what is a rational equation? So a rational equation is just like an equation. So we know what an equation is. We have variables and an equal sign. And the idea is to try and determine what values for those variables satisfy that equation. So in this case, instead of having polynomials on either side, or functions such as the square root or trigonometric functions on either side of the equal signs, we have rational. Functions. All right, just trying to move this over to the right-hand side. Okay, so in part A, we have 9 over y minus 3 minus 4 over y minus 6 equals 18 over y squared minus 9y plus 18. Let's see where we can do this. I think we can do this on the right-hand side. Let's give it a try. Okay, so if we look on the left-hand side, we have a difference of two rational functions. Unfortunately, the denominator is not the same, so we can't just subtract the numerators. So why don't we try and simplify the left-hand side first? Actually, let's do it down here. It's easier. It's a solution. Let's look at A. So I'm going to quickly write it out again. 9 over y minus 3 minus 4 over y minus 6 equals 18 over y squared minus 9y plus 18. Okay, and our plan of attack is to try and simplify the left-hand side. So since the denominators are not the same, we need to put everything over a common denominator. So that means multiplying the first term by y minus 6 and multiplying the second term by y minus 3 in the numerator and denominator, and leaving the right-hand side of the equal sign as is. I mean, if we really wanted to, we could try and simplify or factor the denominator, but I don't think that's necessary yet. So let's just focus on the left-hand side of the equal sign. All right, so now that we have a common denominator, let's add or subtract our numerators in this case. All right. Common denominator is y minus 3 times y minus 6. Again, actually, why don't we just, on the right-hand side, our numerator is 18, let's factor that denominator and see what we get. So it's a quadratic, so that means we will have linear factors. The factors of 18 are 1 and 18, 2 and 9, 3 and 6. Let's try 3 and 6. Let's see if that works. All right. So y times y is y squared. Y times negative 3 is negative 3y. Minus 6y gives us a negative 9y. And negative 6 times negative 3 is positive 18. So that factors nicely. And look at that. It's the same. So the denominator on the right-hand side is the same as the denominator on the left-hand side. That's very handy. All right. So let's focus on our left-hand side. Let's simplify that numerator. So we have 9y minus, what is that, 54? It's a big number. Minus 4y plus 12. And then our denominator, is y minus 3 times y minus 6. Right-hand side, again, 18 over y minus 6 times y minus 3. Okay, let's see if we can simplify that numerator on the left-hand side. It's 5y. Let's see if I can get my arithmetic correct. Negative 54 plus 12 is negative 42. Okay, looks good. All right. Okay, so now we can actually start looking at solving this. Okay, so now that we've gotten to this point where both sides are simplified, we're going to bring everything over to one side. So that means we're going to have 5y minus 42 over y minus 3 times y minus 6 minus 18 over y minus 6 times y minus 3 equals 0. And because we have a common denominator, we can just add and subtract the numerator. So we have 5y minus 42 minus 18, big numbers, over y minus 3 times y minus 6, and that all equals 0. So the only way for a fraction to equal 0 is if the numerator equals 0. So that means 5y minus 42 minus 18 must equal 0, and that's because the denominator can never equal 0. Okay, so let's simplify this. Again, big numbers. So mistake. All right. 5y minus 42 minus 18 is negative 60, right? Yes. And now we just solve for y. So y equals 60 over 5. So therefore y equals 12. So we have solved our rational equation. Now, wow, that's a lot of work. And we need to state our restrictions, though. All right, so the restrictions are, again, when the denominator equals 0. And our denominator, we found that the common factors for our denominator are, or our complete denominator is y minus 3 times y minus 6. So that means y cannot equal 3 or 6. Those are our restrictions. Okay, so that took quite a lot of time to go through. Now let's look at the second question, part B, and let's see if it's easier. I doubt it. They all take a bit of time. So in this case, we have x squared plus x plus 2 over x plus 1 minus x equals x squared plus 5 over x squared minus 1. All right, so first thing is we need to put everything over a common denominator. Let's start with the left-hand side. I don't think it's worth factoring the numerator, but our second term is negative x, and the denominator of that is 1. So if we want to simplify the left-hand side, we need to multiply, let's do this, the second term on the left-hand side by x plus 1. So let's do that. I don't know if we're going to have enough space to do this question, but we'll give it a try. Whoops, not 2, but rather 1. And then we're going to leave the right-hand side of the equal sign as is for now. Okay, all right. Okay, so now let's add the numerators, or subtract the numerators on the left-hand side. Making a lot of mistakes with this one. So x squared plus x plus 2 minus x times x plus 1 all over x plus 1, and that equals x squared plus, actually let's factor the denominator on the right hand side. It's a difference of squares, so very easy to factor. So x minus 1 times x plus 1. Let's simplify the numerator on the left hand side. All right, so we have x squared plus x plus 2 minus x squared minus x over x plus 1 on the left-hand side. And on the right hand side we have x squared plus 5 over x minus 1 times x plus 1. Let's simplify the numerator on the left hand side. So the x squareds cancel out, the x's cancel out, we're left with 2 over x plus 1. That's a funny looking 2. And then on the right hand side we have the same thing. Alright, now there's a couple of ways we can do this. We can cross multiply, cross the equal sign, or we can just move everything over to one side of the equal sign and go from there. So I'm going to do the latter. So I'm going to move the right hand side over to the left hand side. So we have 2 over x plus 1 minus x squared plus 5 over x minus 1 times x plus 1, and that all equals 0. So again, we need to put everything over a common denominator before we can subtract. So the factor for the first term that is missing in the denominator is x minus 1. So we need to multiply the numerator and denominator of the first rational function by x minus 1. So that's what I'm doing right now. And then leave the second rational function as is. And all of that equals 0. So now we're able to subtract the numerators and simplify. So that's what I'm doing right now. So in the numerator we have 2x minus 2 minus x squared minus 5 over x plus 1 times x minus 1, and that equals 0. Let's simplify the numerator. So we get negative x squared plus 2x minus 7 all over x plus 1 times x minus 1, that equals 0. I'm going to be honest, I don't know if we can factor the numerator. I don't know if that's going to equal 0. I think we're going to have to use our quadratic function for that. I'm a little surprised that that's the case, but let's have a look. I just want to make sure we didn't make any mistakes along the way. Doesn't look like we have. No. Alright. So we're going to have to use our quadratic function for the numerator to find the values of x. So remember, let's erase that. So recall that in order for a fraction to equal 0, the numerator has to equal 0. So that means, whoops, negative x squared plus 2x minus 7 must equal 0, or x squared minus 2x plus 7 must equal 0. So now we need to get into our quadratic formula. So remember that. So that means x equals plus or minus b, negative b plus or minus b squared minus 4ac over 2a. Okay, so in this case, I'm just going to quickly do this. A equals 1, b equals negative 2, and c equals 7. So we're going to plug those in to our quadratic formula. So that means we got 2 plus or minus square root of 4 minus, what do we have here? I don't think this is going to work. Well, this wasn't a good exercise at all, was it? So this isn't going to work, which is interesting. So if you notice, under the square root, we actually have a negative. We have 4 minus 28, which is negative 24. We cannot take the square root of a negative number, so therefore, it does not work. It does not work, which is weird. Does not exist I find that interesting. That's okay. Now let's look at our restrictions. Our restrictions are when the denominator equals 0. So this implies our restrictions are when x does not equal 1, or rather when x equals 1 and x equals 1, or when x equals -1. So we do not want x to equal 1 or -1. So those are our restrictions. Let's just review this last exercise because it's a bit a complicated one. I'm wondering if we made a mistake. So we need to find, we started by putting everything on the left-hand side over a common denominator, and then simplifying the numerator, or adding and subtracting and simplifying. We got 2 over x plus 1. On the right-hand side, we factored the denominator. And then what we chose to do is move everything over to the left-hand side, and then we needed to, again, put everything over a common denominator, which we did. And then we simplified the numerator, and then we ended up with negative x squared plus 2x minus 7 over x plus 1 times x minus 1 equaling 0, which means our numerator has to equal 0. Our numerator is x squared minus 2x plus 7 equaling 0. We have to use our quadratic formula. And unfortunately, that gave us no value because we're taking the square root of a negative number, which does not exist for this course. So there's no solution. We did state our restrictions, which occur when x equals 1 and -1.